Hello and welcome back to AGT STEM. Today we're going to be watching a video about barium. So, without further ado, let's hop to it.
So here we have a sample of barium. So barium's going towards the bottom of the group 2, or alkaline metals. So this is a rod of barium we've got in here. Okay, so what I'm going to do, I'm going to hopefully, if I can get the top off. It's really hard. I've got 4 pairs of gloves on here. So it's all quite hard. Everything's very, very difficult to move. I'm going to have to put it down for a second.
Barium.
She has 4 pairs of gloves on. That tells us that barium shouldn't be touched by your bare hands.
Is a heavy element. I believe that this is some sort of barium ore, and it's a really heavy piece of mineral, much heavier than you might expect, seeing its size. And
where'd you get it?
I found this just lying around, well, on a walk somewhere. I think it may be barium sulfate. But I'm not a mineralogist, so I may be completely wrong. But it's a nice piece, and I have it as an ornament in my office.
I'm hoping it'll come out. Aha, there we go. So that's the end of our rod of barium. So what we can do, is barium's quite soft, so we should be able to file a little bit of barium off. And we do that so we can have some barium starting material, so we can react it with things and make barium compounds. There it is. So this is a 100 gram rod of barium. I don't think we've used too much, so there probably is close on 100 grams there.
Because barium is a heavy element, it has quite an important medical use, because heavy elements scatter X-rays, so that if you shine X-rays on a solution or suspension of barium, it looks black. And because the X-rays don't go through. So if you want to take pictures of the soft part of somebody's body, it's easy to take pictures of their bones, but if you want to look at their gut or their throat or their intestines, they don't show up on X-rays. So you feed them what is called a barium meal, if they take it through their mouth, or a barium enema, if they take it through the other end, and you pump in quite large quantities of some barium salt, and then when you X-ray them, the part that's filled up, or just has been coated with it, looks black, or white if you look at the X-ray in negative, which people quite often do. So it's very useful for a fairly straightforward X-ray imaging of people's bodies.
Have you ever had a barium meal?
Fortunately not. It's not meant to taste very nice. I think they put peppermint or something into it to pretend that you're enjoying it, but drinking a large quantity of barium, I think, is not enormous fun. And people use barium because it's really non-toxic. If you took that amount of lead or mercury, you might get a better picture, but you'd be dead.
So what we should be able to do, hopefully, because this barium is soft, we should be able to file a little bit of the barium onto this foil. This is what I'm hoping to do. Let's see if I'm a girly girl now. Oh, I can see little bits coming off actually, but they're very, very small. So they're very, that was a bigger bit. So I'll show you this again in a minute, but you can see how we're kind of starting to clean off the surface. So we're kind of taking that sort of tarnished layer off.
Many elements suddenly become fashionable. And in the 1980s, late 1980s, barium became fashionable as one of the components of the so-called high-temperature superconductors. A superconductor is a material which has zero electrical resistance. And people discovered that a compound of barium, yttrium and copper, barium, yttrium cuprate, and related compounds, when they were cooled to liquid nitrogen temperature, 77 degrees absolute, minus 196 centigrade, became superconductors.
Whoa! Apart from shaky hands, so I've got, hopefully, some very sort of fine barium turnings now. So you can see that, okay, we have a little bit of tarnish in there, but also we have, you know, quite a shiny luster as well on some of the bits.
So there's my barium nitrate. And again, I'm going to add some of my combustion mixture now. We're using the energy of that combustion of the sugar to excite the barium so that we can observe its emission spectrum, or the flame test colour. Again, pour it out onto a heat-proof mat. So, again.
That's a very pretty bluish greenish color. It's very pretty. I like that color.
So this time, again, we saw the same exciting chemical reaction. We saw that same exothermic reaction. Lots of CO2, lots of steam again, but this time the flame was coloured green. And this is the characteristic apple green, which is associated with barium salts. So, much more exciting flame test.
It might look different on the screen versus in real life, because he's saying it looks candy apple green, but this is more blue to us. So, cameras, they mess colors up.
All the elements in this group, group 2, have fluorides that are insoluble. And they're very nice materials. They look like glass, and you can put them in water and they don't dissolve. And this is extremely useful for a technique called infrared spectroscopy, where you're putting essentially heat rays through some sort of liquid to measure the spectrum, how the light is absorbed. And especially if you're using water or something that's wet, salts of calcium fluoride, barium fluoride are really good for making the windows. Here's quite a large window. You can see my eye through it. This one, unfortunately, is cracked, so it's no use anymore. This is calcium fluoride, and calcium fluoride is much cheaper than barium fluoride. So if you can get away with it, you use calcium fluoride for an experiment. The problem is that calcium ions are quite light, and the fluoride and calcium ions vibrate in the crystal through thermal energy, and these vibrations absorb infrared light. Barium is much heavier, so barium fluoride vibrates more slowly, and so it absorbs much longer wavelength light. So in a particular experiment, if you need to get that region of a spectrum, you have to go for barium fluoride instead. I tried calling one of my colleagues in the other office, see if he had a piece of barium fluoride window, can't find it. So you can see calcium fluoride, barium fluoride will look exactly the same, but honesty makes us say this is not barium fluoride.
So we have this one big blob, and we have the finely divided barium as well. Okay, and we're going to try and put that in water and see how it reacts. Okay, so what's happening is we are seeing the barium reacting with the water. I think our big blob is still going, actually. So the barium is reacting with the water. What we're doing is we're producing hydrogen gas, and what I think is probably barium hydroxide. So that's what's precipitating out of solution.
Thank you so much for watching, and we'll see you next time. Stay smart. Bye!